Welcome! In this video, we build an intuitive picture of the North American Cordillera. We will focus on three ranges in the contiguous United States: the Rocky Mountains, the Sierra Nevada, and the Cascade Range. First, a simple east to west transect. On the east, the Rocky Mountains, an older, largely inherited highland. Then, the Basin and Range Province, an extending crust with normal faults. Next, the Sierra Nevada, a west-tilted fault block rising steeply above Owens Valley. And on the coast to the northwest, the Cascades, an active volcanic arc above subduction. Now, the plate boundaries. In the Pacific Northwest, the Juan de Fuca Plate subducts beneath North America at about 40 millimeters per year. This subduction feeds the Cascade volcanoes, and a locked megathrust capable of magnitude 9 earthquakes, the last in the year 1700. South of the Mendocino Triple Junction, subduction is replaced by transform motion on the San Andreas Fault, where the Pacific Plate slides northwest past North America. The Sierra Nevada is a west-tilted block. Active normal faults along the eastern front lift the range and drop Owens Valley. Modern GPS shows northwest motion of a few millimeters per year and uplift around 1 to 2 millimeters per year. The 1872 Owens Valley earthquake produced about 5 to 6 meters of vertical offset. The Rocky Mountains are mostly a stable interior orogen today. The margins are different. The Intermountain Seismic Belt and the Wasatch normal faults are active. Wasatch uplift is about 1 millimeter per year, with occasional moderate earthquakes. Along the Rio Grande Rift, extension is about 1 to 2 millimeters per year, forming basins like the San Luis Valley. In the Cascades and Forearc, subduction builds volcanoes and uplifts parts of the coast by 1 to 2 millimeters per year. The megathrust is mostly locked, storing energy for future great earthquakes. Geodetic data show a subtle forearc bulge. Some key numbers. Sierra Nevada today, about 1 to 2 millimeters per year uplift, higher than its long-term average of about 0.2 millimeters per year. Rockies, present uplift is small, often less than 0.5 millimeters per year, much as isostatic or hydrologic. Cascades, volcanic construction in spurts, long-term average around a few tenths of a millimeter per year, but very episodic. Erosion shapes relief. The Rockies often erode at about 0.1 to 0.3 millimeters per year. Sierra uplands about 0.05 to 0.2. Glacial carving produced U-shaped valleys and hanging valleys in many ranges. The Cascades see rapid construction and destruction, with lahars, slope failures, and heavy rainfall erosion on the west side. To summarize, 1. The Rockies are a legacy orogen with modest present deformation, active at margins like the Intermountain Seismic Belt and the Rio Grande Rift. 2. The Sierra Nevada is an actively tilting, uplifting block at the edge of the basin and range. 3. The Cascades are an ongoing volcanic arc above subduction, with coastal uplift and megathrust earthquake hazard. The North American Cordillera brings multiple tectonic styles into one corridor, making it a natural laboratory for how tectonics and climate shape topography.